Okay, we're going to look at our first root mean squared velocity question in the homework. And so we're given temperature and we're going to find the speed. What we learned about temperature is that it's the measurement of average kinetic energy of a substance. So how much are those molecules moving? And what we can do with this equation is actually solve for the speed in meters per second of a molecule at a certain temperature. And so we're going to use our equation. The root mean squared velocity equals the square root of 3RT, our gas constant, over M, which is kilograms per mole, not grams per mole. So we got to do a conversion there. R, we're listed here as 8.314 joules per mole Kelvin. We'll use joules more. A better unit for this, we'll use joules more in the future, but a better unit for us right now with velocity, and it's the same number, and that's, we could show the conversion between joules, is kilograms per meter squared over seconds squared times moles times Kelvin. So if we put that in, the other thing is temperature tells us the average kinetic energy of a molecule. And so to do gas calculations, we have to use Kelvin because that tells us at temperature, at some point, those molecules stop moving altogether. And that temperature is at 0 Kelvin. So we have to use Kelvin. We don't want to get into negative numbers with Celsius. One of the reasons most of these questions have negative numbers is just to make sure you're converting to Kelvin. So that's the first thing we'll do. We'll do negative 15 plus 273.15 equals 258.15 Kelvin. Now we're going to start 3 times 8.314 kilograms meters squared second squared mole Kelvin times 258. So those Kelvins will cancel. And that's all over 2.02 grams per mole. And we're going to say there is 1,000 grams per kilogram. So if we divide that by 1,000, we get 0.00202. And then we'll take the square root of all that. And then let's look at units. Kilograms cancel, moles cancel, Kelvin cancel. So we're left with meters squared over second squared. That's why we have to do the square root. And so do the math inside first. So we get 3 times 8.314 times 258.15 divided by 0.00202. And we get this large number, 318.7513. And one of the easiest ways in the calculator is to use the caret button and say 0.5 if you have a graphing calculator. Make sure you don't do 1 divided by 2 without parentheses, or you'll likely get the wrong answer. If I raise that to 0.5. A lot of calculators have a square root button too, so you can use that one. Just making sure you do square root of the answer of this number here. I get 1785 meters per second. Since this started with 3 significant figures, I'm going to say 1790 meters per second. So 1790, oops, 0. There we go. So similar for multiple other questions with different temperatures, different molar mass. So the molar mass will change. And so you'll have, let's clear that. You'll have the temperature change, you'll have the molar mass change. And then there's one question that you actually have to solve for temperature. So you're gonna have to, you're given this number, and you're gonna have to square it to get rid of the square root, and then move molar mass over, and then divide by 3R, but only this will be squared. So give that one a try as well.